Hi, this is section 4.6, part 5. Okay, so this is the last one for this section, and it's actually looks scary, but it's not that bad. So let's look at it together. When we cough, the trachea or windpipe contracts to increase the velocity of the air going out. This raises the question of how much it should contract to maximize the velocity. The velocity v of the air going out depends on the radius of your windpipe. Okay, so what it's telling you is your radius is normally at rest, and then when you cough, it contracts, okay? So if R is normal, that's the rest radius of your windpipe, then little r, when you cough, that radius decreases, has to be a value between 0, which would be really bad because you can't breathe, and the resting radius, which is big R, okay? The average flow velocity can be modeled by velocity at little r, that's when you cough, is equal to A times big R minus little r times r squared centimeter per second, where A and R are positive constants. The value of A depends on, in part, of the length of the trachea. What value of R will maximize the velocity? Okay, so really quick, remember we're going to keep this in mind that little r has to be a value between 0 and big R. And R is your radius at rest, okay? We're lucky with this one because we're already given the function, like we don't have to figure that out. Because the function is v at little r equals A times r minus little r times r squared, okay? And remember, it's saying that A and big R are positive constants. So what we're going to do here is we're going to make this look a little bit better. We are going to multiply this out. And when I multiply this out, I get A times R minus A times little r, and then I have RQ hanging out here. So R squared. So when I do this, I get A times big R times little r squared minus A times little r squared makes R cubed. Okay, so here's my function. Now, if I want to figure out what's to maximize something, I need the derivative. So I'm going to take the derivative of this function. And remember that A and R are positive constants. So when we had positive constants, we just left them alone. And that's what we're going to do with this. So I'm going to take the derivative of r squared. So that's 2 little r. So I have 2A big R times little r. That's the derivative of the first one. And A is the constant, so I'm going to leave it alone, and I'm going to take the derivative of r cubed. So when I take the derivative of r cubed, I get 3 times A r squared. And that is my derivative. Okay, remember, I have to solve this. I got to set this equal to 0 and solve it. So don't panic. It's actually, once again, not that bad. So if I factor out a little a and a little r, I'm left with 2 big R minus 3R. Okay? Now I'm going to set that equal to 0. So A times little r times 2 times big R minus 3 little r equals 0. So if I set AR equal to 0, remember I'm trying to solve for R, right? So R equals 0 over A, which is 0. This is a problem, and it can't be a value because of my stipulation. Remember that little r has to be a value between 0 and big R. Okay, so I can't accept this answer. So let's look at the other one. 2r minus 3 little r equals 0, and I'm trying to solve for little r. So I get negative 3 little r equals negative 2 big R. So R equals negative 2 R, big R, over negative 3. Okay, so R equals 2/3 big R. Okay, All right, you might be saying, okay, that's nice. That's, the critical number, but how do I know if this is going to be a minimum or maximum? Well, the only thing we can do, because we can't really use test points on this guy, is we can find the second derivative and then look at it. So that's what we're going to do with this. So just as a reminder, the derivative came out to be 2a big R little r minus 3a r squared. Okay, so if I want to take the second derivative, remember a and big R are constants. So if I take the derivative of r, it's 1. So I'm left with 2a big R. And then r squared is the only thing I can take a derivative here. So 2 times 3 is going to give me a negative 6a little r. Okay, so that's my derivative function. So now what I'm going to do is I'm going to test it with the critical number. So the critical number we found to be little r equals 2/3 of big R, right? Or I should put that together. Let's just put 2/3 big R. Okay, so let's test it out. So I'm going to plug it into the second derivative, 2/3 big R. So what does that look like? It's 2a times r minus 6a. Now where I find little r, I plug in 2/3 big R. So basically I get 2a times large R, and then 2/3 times 6. 6 and 3 cancel each other, and I'm left with 2. So negative 2 times 2 is going to be a negative 4ar. So this basically results in negative 2ar. So all right, so my result is a negative. So remember, a negative for the second derivative means concave down. So that means a max at r equals 2/3 of the resting radius. Okay, and there we go. So that's it. Hope you guys learned some stuff, and I will see you guys in class.